In this part, we are going to introduce a WLAN security background. WLAN is a wireless local area network. All the signals are transmitted in the open space. So it's facing several security risks. For example, the first one is open physical channel, and it will lead to the information interception because attackers can receive the signals, and by using some tools, they can decapsulate the packet and get the information inside. Another is called attack software on the internet. Because in the internet nowadays, it's more convenient for the attackers to get a lot of tools. By using these tools, it's easier for them to attack a network. Except for information interception, DOS attack is a very serious problem. By DOS attack, attackers can interrupt the service of the WLAN, and all the users cannot access the internet anymore. It's terrible, right? And compared with a wireless network has higher vulnerability to be attacked. After knowing the security background of WLAN, let's see some security issues WLAN are facing. The first is called eavesdropping. The unauthorized users eavesdrop on radio signals sent between wireless STAs and APs. Since it's a passive attack, because the signals is transmitted in the open space, so we just need to receive it if we want to attack the WLAN, right? So it's difficult to detect this secret, and of course it's difficult to prevent it. WLANs are more vulnerable to eavesdropping than the wired LANs. The second is called unauthorized access. A user can access the WLAN system by acting as an authorized user. So to prevent this issue, we should have a method to distinguish if the user is authorized or not. And the method is called authentication mechanism. By authenticate all the users, we can figure out if they are authorized or not, right? And the second is a user set a forked AP to deceive wireless STAs and capture their usernames and passwords. It means that in a WLAN, if the attacker want to get the username and the password, because we have used the authentication mechanism, so they cannot access the network without username and password. So they set a forked AP, and there could be some authorized STAs maybe associated to this AP. And to log in the network, they should enter the username and their passwords. So in this way, the attacker can get the parameters. And after getting these parameters, they can access the WLAN system. Okay, next is interference and human intervention. The interference source could be, for example here, the microwave oven, or even some other equipment with high current could be an interference source. And the human intervention means attackers use high power transmitters. So it will cause interference to the WLAN network. And the last is a physical secret. And no matter wired or wireless network, both of them are facing the physical secret. And for the wireless network, the physical secret could be APs are possible to be blocked by snow or ice, especially the outdoor APs, right? And the cables could be cut, or the antennas could be deflected or broken by the wind. These are all the security issues. And about the WLAN security, what we are focusing on is about the authentication, how to avoid the unauthorized users access the network. Before we introduce how to improve the security of the network, let's see the interaction process between AP and STA. If the STA want to access the internet through this AP, firstly, STA will scan for the signals. So the first step is scanning. And then after getting the wireless network, for example, after scanning, we find a specific AP. It can offer the internet access service. So the AP will ask the STA to authenticate. So next step is authentication. And in the authentication step, STA should enter, for example, the username and the password. It's based on the authentication methods we deploy in this scenario. Okay, and after succeed in authentication, next step is association. Association means STA1 in this figure can only access the internet with the AP here. Okay, after association, next STA wanted to send data traffic. And before it sends data traffic, it will send an RTS. RTS is a request. Means I want to request for the data transmitting in this channel. And after receiving the RTS, AP will feedback an CTS. CTS means, okay, you can use this channel to transmit data. And at the same time, AP will broadcast the CTS. So the other users or the other STAs in the WLAN will receive it. In this way, STA1 knows, okay, I can use this channel to transmit data. So it will send out frames. You can see here, number 3, send out frames. While at the same time, the channel is busy. So after receiving the CTS, STA2 knows I cannot use this channel at this time. So STA will wait for a moment. And in this way, we can prevent the collision occurring in the network. And once this frame is received by AP should feedback an ACK, an acknowledgement, to STA1 immediately. Only after receiving the ACK from AP, it represents STA has transmitted the frame successfully. This is the interaction process between the AP and the STA. And the whole process can be divided into 3 passes. First is scanning, and then authentication, and then association. And the last step is data transmitting, right? Data sending and data receiving. Okay? And about each pass, first about the scanning pass, the 802.11 MAC layer searches for and joins a network through scanning. And the scanning can be divided into active scanning and passive scanning. Let's see what's the difference between them. First is the active one. STA sends probe request frames through 11 channels in sequence to discover an AP with the same SSID as that on the STA. If no AP with the target SSID is discovered, the STA keeps scanning. So the active scanning means the request is from STA. You can see STA send out a probe request. And in this request, the SSID is none because STA even don't know which network is available. So of course, it will not carry the SSID inside. And the request is broadcast. So in the coverage, no matter AP1 or AP2, even more APs, they can receive the probe request. And after receiving that, if the AP can offer the network access service, they will feedback the probe response. For example, here, AP2 will feedback the probe response, says that, okay, you can access the network through me, right? This is called active scanning. Next is passive scanning. Passive scanning will take long time and is power saving for STAs. In the passive scanning, STA waits passively. So the reason why we call it passive scanning because the STA just wait for some information from the AP, so it's passive. APs send beacon frames at intervals. You can see the AP send out the beacon frames, and these frames provide information about the BSS in which the AP is located. So it's a kind of advertisement. By sending out beacon frames, AP tells all the STAs that, okay, here are the BSS information, and you can access the internet through me. And after receiving this beacon, if the STA has a network access requirement, so they will associate with the AP, right? So this is about the scanning paths, active scanning, passive scanning. You should know the difference between them. And in the active scanning, let's see the messages exchanging. Here we have two APs, AP1 and AP2, and STA want to access the internet, so it's scanning the network for some available devices. It sends out the probe request through each channel and obtains the SSID information from the probe response, because after receiving the request, both AP1 and AP2 will feedback the probe response. In the probe response, it carries SSID information. Then, in this case, STA has received two probe responses. So which one or which AP it will associate with? It will compare the signal strength from AP1 and AP2. STA will associate with the AP has a higher signal strength. So here, based on the information we got, maybe AP1 is closer to STA, so maybe STA will associate with AP1. Okay, this is active scanning and passive scanning. Let's see. STA discovers a network by listening to, pay attention here, listening to beacon frames sent periodically by APs. You can see the AP send out beacon frames periodically. An AP broadcasts beacon frames at an interval of 100 microseconds by default. An STA discovers a network by listening to beacon frames sent periodically by APs. You can see the AP is sent. This is AP is sending out beacon frames each 100 microseconds. And after receiving that, STA knows, okay, through the AP here, we can access a network. If I need, I can associate with the AP. Okay, this is called the passive scanning. After knowing the working process of the communication between AP and the STA, then next is authentication path. STA discovers the AP with a CMSSID as STA. And the STA selects the AP with the strongest signal based on the signal strength of the APs. Then STA enters the authentication path. Only authenticated STAs can access the WLAN. So in this way, we can improve the security of the network. While the how to authenticate all the STAs, here it shows us 4 different authentication types. The first is called Open System Identification Authentication. Actually, you can think it's non-authentication. Because if we use the Open System Identify Authentication, once the authenticated server received the request information from the STAs, they will immediately feedback a succeed response. Okay, and here I think you may get a little confused. Since it's non-authentication, so why we should use it? Normally, the main function of open system identifier authentication is to identify that the client which is requesting for the network or requesting for the authentication is a wireless device. Okay, so this is the main function of it. It can not actually improve the security of the network. And the second type is called shared key authentication, WEP. From the name, shared key authentication means the authentication client and the authentication server will have the same key. The key is shared. And during the authentication server just need to confirm that the authentication terminal or the authentication client have the same key with me. So it's authorized user. And this key will also be used to encrypt data. Okay, this is the second type. But the second type have a very obvious shortage because the shared key is used to authenticate and it's used to encrypt the data. So if the attacker got the shared key, it can access the network and at the same time, it can get the information in the whole network. So it's not that secure, right? So this is a second type. And the next is a WPA PSK authentication. Actually, it's also a kind of shared key authentication. But what different is that the key in WPA PSK authentication is only used to authenticate. It will not be used to encrypt data. So we have solved the problem what we have mentioned in type 2. So it's more secure than type 2. And the last is 802.1x and EAP authentication. Compared with all the others, 802.1x and EAP authentication has a highest security level. So in some scenarios that have high security requirements, we can use this type. Okay, this is about the authentication path. And next is association. After an AP returns authentication information to a STA, the STA is authenticated. So it will enter the next step, which is association. The STA establishes an associating relationship with the AP by using the messages here. STA will send the associating request to the AP. Means I want to associate with you. And after receiving that, AP will feedback an associating response. Right? And after getting the associating response means we have finished the associating path. And then the STA can exchange data with the AP now. Okay, this is the association path. Okay, so I think until now you have mastered the working process between STA and AP. The first is scanning and then authentication and then association. And after that, the data can be transmitted between STA and APs.
Okay, except association, there is another path which is called reassociation. Let's see when it will happen. When an STA moves from the coverage of one AP to that of another, actually, what it means here is called roaming, right? When the STA is roaming from one AP to another, re-authentication and reassociation are required. Let's see, how does it work? Now this is a STA, right? And it's moving from left to right. So obviously, it's getting more and more close to the new AP. So it will detect that the signal of the new AP is shown. And at this time, it will trigger roaming. Okay, and let's see. Firstly, it will send a reassociation request to the new AP, means that Okay, now I'm the STA, and I have already associated with the one AP. Now I need to reassociate with you. Okay, and this is called reassociation request. And then the new AP will respond to it, send a reassociation response, means, okay, I have received your request, and you are allowed to associate with me. So after receiving the response, STA cannot associate with two APs at the same time. So it will send a deassociation message to the former AP, means that I do not associate with you anymore. Okay, so this is called reassociation. It happens when the STA roams from one AP to another.
Okay. So until now, let's summarize these parts. Here we have two APs, APA and APB. The STA is showing here. First, the STA broadcasts an access request, and APA and APB send a request response. The STA compares the quality of service of APA and B. Assume that the STA selects APA. For example, APA has a higher power strength. Okay, and next, the STA send an authentication request to APA, and APA, of course, will feedback the response, right? Confirms the authentication information and return a response. If the authentication succeeds, so next, the STA send an association request to APA. APA, of course, will confirm the association request, and then will be data transmission. Okay, this is about the network security background in WLAN. Okay, after finishing this part, let's see a practice question. In an enterprise wireless network, to satisfy high network security requirements, which authentication type is suitable? A. Open system authentication. B. Shared key authentication with WEP. C. WPA PSK authentication. D. IEEE 802.1x and EAP authentication. As what we have said at this part, choose D. 802.1x and EAP authentication have the highest security level. So to satisfy the high network security requirements, D is suitable. Okay, that's all for this part.